Thanks everybody for joining us today in this special ISACA workshop. We're pleased to invite again Dr. Thomas Lee of Vivo Security. We are recording this and it'll be available on the ISACA San Diego website in a couple of days, both the presentation itself as well as the slides and related template. We're going to be doing 3 polling questions through the seminar, through the workshop, if you will. And we're doing that so that people can get their CPE, especially if they're licensed. So we're doing the 3 polling questions as required by the National Association of State Boards of Accountancy. And let's see, I think that's about it. Thomas, why don't you kick it off?
Sure. So thanks everybody for coming. I really appreciate it. Like Tim said, this is actually a workshop, not a webinar. So I will really be teaching you, and together we will be calculating probability for third-party data breach. When you get done, you're going to know how to do this calculation. You're going to know how to calculate the frequency. Just to introduce myself, I'm Thomas Lee. I'm the CEO of Vivo Security, and we're a company, we develop regression models for cybersecurity. And then I gave a talk months ago to ISACA San Diego just about our models, and Tim was there. And ISACA liked the talk, and Tim and I struck up a friendship. And we started working together on a white paper. Originally, it was for auditors. We're still working on that one, but in the meantime, we turned out this white paper that you see on the screen. And then in another talk that I gave, Patty was there, and it was a third-party risk management talk, and it really clicked for her. And the 3 of us had been working together, trying to finish the white paper and also try to teach this calculation. So Patty's name here is also in the white paper. I know Peter is one of the attendees. He's at the bottom of the white paper. He's made a really big contribution. But so let me just do you guys have any comments? Can I say that definitely reach out to Patty. She is an expert in being able to do this calculation. So if you have any trouble, we're going to be giving you a spreadsheet you can use a calculator. But she's a really good person to contact for doing this. Do you guys have anything to add before I go on?
Yeah, I was going to add, as Thomas takes you through the calculation, it may take it a while to click because I know it took a while for me when Thomas and I were first getting together. And with that in mind, this webinar is basically scheduled for an hour. However, we added an extra 30 minutes at the end in case all of a sudden, as you get towards the end, it clicks and you go, darn, I really want a chance to ask a question or think about how this affects my own company. So this webinar actually runs till 1:30. So you have a chance to ask questions or do calculations afterwards as well.
Yeah, and I encourage questions as we go along here. I'm going to be working with Patty. She's going to be you. And then if you have any questions, she's going to bring those up as we go along here. All right, Patty, this is your slide.
Great. Thank you. First, I'd like to thank ISACA San Diego for having us today and for hosting this workshop. We appreciate everyone who took the time to attend. This is a place where we can talk openly about our challenges with third-party risk assessments. Despite our best efforts, third-party breaches still happen. We all do an enormous amount of work to assess the risk with our third parties. But I think we're missing something, and we found it. Imagine if you could predict when a third-party breach could occur or how big it could be. We're going to share with you a number of things today that will help you answer those questions. In other words, we're going to be moving the needle. It's time to move the needle. Some of the things we're going to share with you today are simple, a simple formula, which we've named lovingly the Breach Probability Index. We're open to feedback on that title as well. But this is a very simple formula that you can use right off the bat to help you calculate the probability of a third-party data breach. How it came to be and the explanation of it is all in the white paper. We put the link in the chat for everyone to get. In addition to that formula, we're going to be sharing a template that automates the process. So there is a bit of math here, use of calculators. And for those who just cringe at the thought of that, we have a very template that you can just quickly enter your number of third parties and it will calculate for you. There's also much more detail in the template. And the idea behind it is that you have this takeaway with you when you go back to your places of employment. You will have something that you can refer to and actually use. We're going to give you guidance on how to judge what's acceptable and how to explain it to your leadership. And we're also finally going to wrap it up with an introduction to a new concept called collective risk budgets. So we're going to ask you to take a bit of a paradigm shift and join us on a journey today to help you think about this type of risk in a different way. Okay.
Fantastic. Okay, here we go.
Here we go.
Can you all please download the white paper and the template? And I think Patty's pasted both of these in the chat, right? Yep. Can you please click on that? And I mean, really download them, and especially download the white paper. And when you download the white paper, please open it, because I'm going to help you navigate the white paper. It's got everything in it. All right, Patty, let me know when you got it downloaded.
I've got it.
Okay. I hope everybody is got it. Let me move on. So if you haven't, keep working on it. But I want to just, if you could scroll down in the white paper, if you've got it open, to the table of contents. And I'm going to be taking you a few places, so please keep that open. But I want to begin by telling you how the white paper is organized. Oops, I'm sorry, here.
Hey, before you start, everybody's asking for the template link, so we might as well go ahead and drop it.
Okay, I'll put them in.
Okay, so let me tell you how the white paper is organized. There's really, it's broken into two halves. So the top half is for somebody that's actually going to do the calculation. It's for us today. I mean, we're going to be going through a couple of examples on how to do this calculation. The bottom half is for somebody that's going to judge the calculation. This might be your boss, for example, who wants to know where this calculation came from. It might be somebody on the board of directors. If you're in a bank, a big bank, it would be the model validation team. The bottom half gives the mathematical theory, where it comes from probability theory, where some of the numbers come from. And we will be looking at part of that today. So that's how it's broken up. Okay, so the second thing is we really are going to be calculating. And so could you please get out your calculator and get it set up correctly? And I really recommend using your phone. If you have an Android phone, I don't have an Android, but I understand there's a menu that looks like this on your Android phone, and that's what the calculator looks like. If you have an iPhone, I know how to get the menu, this menu. If you swipe from the upper right corner to the bottom left, you can bring open this menu. And that's where the calculator is on your iPhone. The other thing is we need to get into scientific mode on your calculator. So this is what my calculator looks like on my computer. There's right down here in the corner is a calculator symbol. If you click that, you bring open this menu. Could you please select scientific? And the reason is we're going to use the 1/x key. And that's going to use that for calculating frequency. So just make sure you can get to the 1/x key. Patty, do you have your calculator open? Okay, good. All right, hope everybody's found your calculator. Okay, so let me start with the current approach. The current approach, I understand I'm not a third-party risk manager, but somebody hands you a third party. It's got some inherent risk. You begin your due diligence process. Maybe you apply cybersecurity controls, and when you're done, there's some residual risk. It may be very small, but there's some residual risk. It's not zero. Due diligence is, people have explained to me that SOC 2 reports, SOC 2 type 2, it may be questionnaires, maybe you get a bit site score. That's due diligence. Do you got anything to add, Tim, or do you want to wait?
Well, yeah, there's sometimes site visits and, and it could be multiple times and that but the real issue with SOC 2s, of course, is you got to hope that your vendor, has their SOC 2 set up so that they address controls that really apply to your risks. And that isn't always the case.
Okay, but I'm going to tell you in a few slides, you're doing a good job. But the point is there's some residual risk left over, and it's not
Excuse me,
zero.
Tom. Sorry, Tom. There's a question, hand raised from Matt Stamper.
Sure.
I don't see anything in the chat, though. Did you have
Yeah,
a
Matt
question?
said, yeah, Matt has down below, he asked about FAIR, I think.
Oh, sorry, I answered that. FAIR is not part of the calculation.
But
Sorry.
we can
No,
let him
this isn't
talk.
fair. Well, when we get to this is not fair, and not at all. This is based on probability theory. You'll really come up with a frequency, and you'll be making a testable prediction. You'll see, but fair could be very much part of the due diligence, but this is beside fair. Okay, so the concept I want to communicate here is that residual risk accumulates. You've got residual risk from all of these third parties, and it accumulates. And it may be very small, but it's not zero, and it does accumulate. And to help you with this idea, I would like to make an analogy with getting a hole in one in golf. I'm not a golfer, but I know that it's a really low probability. Maybe it's a 1 in 1,000 probability. I really don't know, but it's very low probability. But not if you have enough golfers. If it's 1 in 1,000 and you have 1,000 golfers, guess what? You'll have a hole in one. And there's the equation for it. So it's just a sum of the probabilities for each one of the golfers. And if you add them up, you can say what the probability is. Now, if you've never seen this symbol before, don't be intimidated by it. This is called sigma, and it's math shorthand for just add up all the numbers. So if I had n golfers, it's just saying add all the golfers, P1, P2, P3. If I had 1,000 golfers, I'd have 1,000 p-values here to add up, and that would look ridiculous. So mathematicians have come up with this shorthand to indicate just add up all the numbers. So don't be intimidated, but it's important to know what this means. Okay, the other thing you should know is this is not my opinion. This is one of the most basic principles of probability theory. If the incidents are disjoint, that is, they can't happen at the same time, it's called the third axiom of probability theory. If the events can happen at the same time, for example, like data breaches, then it's called the linearity of expectations. But it's important to know this is just one of the most basic principles of probability theory. Okay, before I go on, just to help you remember these slides, so you don't forget, I just want to tell you about a small snag that happened as Tim and Patty and I were practicing this. Patty looked at this slide and said that there's no women golfers in it. So I want you to know that I added a woman golfer here, and Patty said, well, that's not enough. So I asked her, how many golfers do you want, to be women? And she said, well, half of them. So I made up this slide. And so half of the golfers are women. But I want you to know it doesn't make any difference. The calculation is still the same. All I need to know is the probability for each one of the golfers, excuse me. And I kind of like this slide now because it looks less predictable with all the women in it, but it's still just the same. And I could calculate the probability if I could just know the probability for each one of the golfers. Now, Patty's made up a slide here. I'm going to take you to it. Patty's going to tell me she made an animation, and I'm going to run it when she tells me that, just to help you understand the concept here. Tell me when to go, Patty.
Yeah, I will. This slide is really intended to show the concept of the veiled cumulative risk that exists when you work with multiple third parties. The blue icons represent your risk assessments that you perform now for each third party, and the red icons indicate that little bit of residual risk that is pertaining to each one, and it builds up as you keep adding multiple third parties. So go ahead and click, Tom.
Okay.
Just a simple illustration to show you that each time you add a vendor, you're building up your cumulative risk. Think about it like this. Risks don't exist in silos, right? They build. And another way to think about this is your exposure to sound. If you were to go to a rock concert every day, your hearing would most likely be, your risk of hearing impairment would be much higher than if you just went once in a while. Same thing with sun exposure. A little bit of sun exposure every day, no problem, but it accumulates if you extend it to longer periods of time. So we just wanted to give you some sort of real life concept view here of how we're going to use this formula to predict the frequency of an expected data breach based on residual risk.
Okay. Good demonstration. We've got to by the rules of ISACA or whatever, we've got to stop and take a poll for the auditors to get their CPE. Is that right, Tim?
Yeah, that's right. So here's the first one.
I don't have to take this, right, Tim? It popped up on my screen.
Well, when you get your license, Tom, you'll have to do that.
Okay.
Okay. Let's see, 51. So just a minute more or so to get everybody in.
Patty showed me these are hard questions. I'm glad I don't have to take them. I don't see
Thanks,
the numbers
Matt.
change.
Appreciate the comment.
Questions are
Okay,
great.
looking kind of steady. I'll end it at this. And let's just take a quick look. So what we had is 55% said the number of third parties in use could expose your data. Type of security came in second with 30%, and the others were smattering across the remaining three about the size of the organization, the risk score, and the industry reputation.
Yeah.
Okay.
And yes,
someone
Matt's-
made the comment. Yeah. Okay. Note to self, we'll move this up further in the webinar. Thank you.
Well done, Matt.
Hey, can I continue?
Yeah.
Okay. So back to the golfer slide. Like I said before the poll, so this equation is a true and complete and inaccurate mathematical description of the problem for the probability. The only problem with it is I need to know the probability for each one of the golfers, which is kind of a real obstacle. Okay, so it turns out that there's a much easier calculation that we can use, and this is it. All we need to know is the average probability for a golfer to get a hole-in-one and how many golfers there are. And believe it or not, this is just as accurate and just as complete at calculation And if I switch to third parties, it's the same concept. Again, this equation here is a true and accurate and complete mathematical description of the problem. I just need to know the probability for each one of the third parties. In the same way, I have a much simpler calculation that I can do. If I can just know the average probability for a third party to cause a data breach and the number of third parties that could cause a data breach, I can make the same calculation. And this is much easier if I had hundreds of third parties. The equation on top would be much harder to implement. The equation on the bottom is I just need two inputs, the average and the number of third parties. And we've named this because we're going to be using this equation over and over again. We gave it a name and we called it the breach probability index, or BPI. And I would really like to know, do you like this name? Can you think of a better name? If you could put something in the text, we'd really appreciate it. The industry needs to own this equation. It's a magical equation, and you'll see that when we start using it. So think of a name. This might be the workshop where we come up with the final name for this thing. Okay, so I want to show you where we derive this equation. So I was telling you the white paper is divided in half. The bottom half is for judging the calculation. On page 24 in the second half, the mathematical basis under third-party breaches or count outcomes, we derive this equation for you. And you'll find it in figure 3. And I'm going to step you through this. Believe it or not, I don't know if you've gone to a webinar where somebody does algebra, but we're going to do it here. So let me just step you through. So this is the equation from probability theory. It's either the third axiom or linearity of expectations. If we start with this equation, just remind you of your algebra. If we multiply and divide by the same number, we leave the equation unchanged. So we're going to multiply and divide by n. In the second step, I'm going to rearrange the ends. Just to remind you again from algebra, it doesn't matter the order in which we do multiplication and division. So I'm going to move the n underneath the sigma. And I want to point out that the sum of the probabilities divided by the number of probabilities is just the definition for average. It's the definition for average probability. So I can replace this with p average. And we have just derived equation number 4, or the breach probability index. So when you take this to your manager and your manager says, where the hell did this equation come from? Take them to this part in the white paper and step them through. This is like, I don't know, I got to tell myself not to say this, but this is like junior high school algebra. Okay, so this is our equation, the breach probability index. All we need to know is the number of third parties, and we need to know the probability, the average probability for a third party to cause a third party data breach. And I want to tell you, our good luck is that we find the same average probability for all companies that we analyze a third party list for. And it's 0.066%. 0.066% annual probability for causing a third-party data breach. And I want to tell you, this is a really low probability. It's a really good number. In a couple slides, I'm going to teach you how to calculate the frequency, but you just invert this, and the frequency is once in 1,500 years, once in 1,500 years. So that's an incredibly low probability. So, and I want to tell you, I've shown this equation at other talks, and I've had third-party risk managers say, I don't like this equation because it doesn't show me the hard work that I've done in due diligence. Well, I want to tell you that all that hard work that you've done in your due diligence is showing up in this very low average probability. The 0.066 reflects all the hard work you've done in due diligence. But we are missing something, and that's the N. And you can see that that is essentially the risk. If the N is 10, the risk is 10 times higher than this average probability.
Wait, hold on, Thomas. We got a question from Val that says, is this breach indicator calculation meant to calculate probability for a given vendor or the general probability for the number of vendors in place? E.g., go ahead.
Well, the average probability for any particular vendor is once in 1,500 years, 0.066. But this calculation is for the cumulative risk. And that's your risk. That's the risk of, that's the likelihood of the hole-in-one at a golf tournament, and this is the probability for your organization. So it's important to understand that it's the cumulative risk that you need to be concerned about. The fact that you have 100 vendors or 200 vendors or 500 or more, that's the risk. And this is the calculation for that probability. Is that good? We could talk about this some more if you'd like. And it is possible to know the probability for any particular vendor, but you need a regression model. And we do have a regression model that we could talk about that later. But this workshop specifically for the aggregate risk, this cumulative risk. All right, I want to tell you where the 0.066 comes from. Okay, so
that's key, Thomas.
Yeah, exactly. So if you go to page 28 in the white paper under the mathematical basis again, you'll find this picture. It's a graph, and Tim has emphasized the importance of this for auditors. They're going to want to know where this comes from. What we've done in this graph is we've received vendor lists from a lot of different companies, and I've selected out a bunch of companies that sort of represent a cross section of different company sizes, different industries, different regulatory authorities, even different countries. And I've plotted the probability distributions for the vendor lists that we've been given. Now, you should know we have a model. We can calculate the probabilities for the individual third parties. And that's what I've plotted here is the probability distributions for the individual third parties. And what's remarkable is we get the same probability distributions for all the companies that we look at. Maybe it's not a surprise because pretty much everybody follows the same methodology: questionnaires, SOC 2 reports, bid side scores, but we all get the same probability distributions. And if we calculate what the average probability is, we all get the same average probability, 0.066% within a standard deviation. The standard deviations in the white paper, it's 0.027. And I'm showing the standard deviations here with the dash red curves. So the most likely average probability for your organization is the 0.066%. Let's see. Were you gonna, Tim? Do you have any other comment? Tim has a perspective from an auditor.
That we see a sample of companies over here, but really, where did you get? How can you be confident that 0.066% is representative, truly representative?
Yeah. So to that point, this is really just a sampling. So you should know that we've analyzed truly thousands of third parties in getting this calculation, 0.066. I got to say that if you took statistics, you know that you don't really need that many samples to figure out what the average is and the standard deviation, but we really have derived it from thousands of B2B companies that have been identified as being able to expose large amounts of data. So that's the first thing. The regression model that we use to generate these curves, you should know that's based on millions of companies in the United States. that we've analyzed. You should know that the regression models we can calculate probability based on staffing level. But you should also know that it's not important, that you don't need an accurate regression model to figure this out. And on page 29 in the white paper, we explain if you're in a larger company, you've experienced third-party data breaches already. And we explain how you can calculate this P average based on the data within your own enterprise. Here's just a quick screen grab to show how the calculation would go. For example, if you're in a larger company, you've had 2 data breaches, third-party data breaches over the last 7 years, and you have 600 vendors. Then we show you how to do this calculation in the white paper. The average probability is 0.047, which is within the standard deviations that I'm showing here on the curve. So you should know the most likely number for your organization is 0.066. You got a 70% chance of being within the standard deviation, but you can calculate this for your own enterprise. Even if you're in a company that's never had a third-party data breach, you can at least calculate an upper limit on the P average. And that's also explained in the white paper. I just want to mention, to remember the number, if you round it, 0.066 comes to 0.07 or 007, James Bond. So, and I want to credit Christine DeHurst in Toronto for discovering that now you can go away. You won't forget the number. James Bond, just remember that. And it's a really good number. This slide is just to remind you. Good.
Yeah, Thomas. So Saskia asks, so you only checked for official data breach notices? You probably want to talk about a little bit about how you got there.
Yeah, that's a good question. In fact, the probability model that we developed, which is it's not important for this, we're teaching how to do this without a probability model. But indeed, we built a regression model off of the data breaches that were notified, that were sent in, the data breach notifications to the various state attorney generals in the United States. Our favorite source is Maryland Attorney General because it goes all the way down to one Maryland resident affected. I do have a talk on that model, but indeed the probability is for reportable PII data breach. And that's what 0.066% represents, is the average probability for a reportable PII data breach, not an intellectual property data breach or sensitive data, but ones that have to be reported by law in the United States. All right, this is just
someone's asking, is this going to replace people?
The calculation? No, it's not gonna. It's all about people. And in fact, I have a slide coming up. It's my Homer Simpson slide, and it's about us. So this is about us, and it's not about replacing us. The point of this slide, I just want to remind you of your statistics. Standard deviation means that 70%, almost 70% of the cases are within the standard deviation. So again, the number that we come up with is 0.066. 70% of companies, this will be the right number for them, or at least within the standard deviation. All right, let's calculate. This is a story problem. You remember back in the old days when you had story problems. I have a company, so let's calculate here. I got a real problem here. We got a company, it's got 13 third parties and that it's sharing data with. So this data is not encrypted, it's not obfuscated, and this data is within the enterprises of these 13 third parties. And so if they were to have an internal data breach, or they were to have a third-party breach themselves, they would expose your data. And so let's calculate the probability of this data breach. And by the way, let's imagine the company said that all of their records are being shared with these 13 third parties. So it's not broken down by data breach size here. So I'm going to do the calculation. I hope you can do it. Go ahead. What were you going to say, Tim?
So how do you know it's just 13 parties? How do you know it's just 13 companies?
Well, that's the auditor talking. I'll tell you, Tim, I'll tell you a story when I get through here, but indeed, that's the most difficult question to answer. And it's because companies haven't understood that the number of third parties matter. So they're not very careful in getting this number. I'll tell you a quick story when we get through this calculation. This is a very realistic calculation. Okay, let's get out our calculator. This is my calculator. I recorded it. I'm going to do the calculation two different ways. I have a percent key on my calculator, so I'm going to do it the first time with the percent key and then the second time without the percent key. Don't laugh. It's harder than you know to do a calculation with percentage. So 13 third parties times 0.066%, and we get 0.858%. I hope you're all doing this with your calculator. Patty, I forgot to ask you if you're doing it.
With you.
Okay, now I'm doing it again. Now I'm not going to do it without the percent key. So I'm putting 2 zeros before, then 0.66. And I got the same result. It's 0.00858, or if I turn it into a percentage, I just move the decimal point over 2 digits and it's 0.858%. Patty, did you get that?
You did.
Okay, don't hit all clear. Leave it on your calculator because we're going to use this in a moment. Okay, so this is the probability that I just calculated. It's roughly a 1% probability. Okay, so now let's calculate the frequency. Okay, and you should know the frequency is just the inverse of the probability. So all I have to do is take 1 and divide by the probability. And this is why we went into scientific notation. We're going to use the 1 over x key. So are you ready, Patty?
I'm ready.
By the way, if you deleted this from your calculator, just enter it quickly. It's important to have the muscle memory here to do this calculation. So here it goes. So I'm just going over here to the 1 over x key. I'm going to click that. And then I'm going to hit the equal key. And then we got our answer. 116.5, or roughly 117 years. So here's the result. So what? So this is a really low probability. Essentially, this data breach won't happen. It's once on 117 years, or 1% probability. So what would people in this company think? They would think, okay, let's move on. We don't need to really be worried about a third-party data breach. We've done our due diligence. The probability, the average probability is 0.066, but the number of third parties at this point isn't really a problem. Now, I
think it's important. It's important to point out to everyone that, that doesn't mean there won't be a breach in year 5, or there won't be a year in year 10, because that's the beauty of randomness. However, 117 years is just that. There theoretically should just be one breach in 117 years.
On average is the important thing to say. Yeah, it doesn't mean if you think about this number, if I had 117 companies with this 0.858% probability, it would happen every single year among those 117 companies on average. But for me, it's very unlikely that I'm going to be that one company out of the 117 companies. So for me, I could feel pretty comfortable. It ain't going to happen. It's just extremely low probability. Now, just To Tim's comment, that this is an accurate calculation, assuming that the data in the calculation that we put in is accurate. And I can tell you this is a realistic calculation. In fact, this comes from a company that I work with that gave me 13 third parties. And, they actually gave me the names of the third parties so that I could actually do the equation one calculation. And I'll just tell you, the numbers that they gave me were not correct. One of the companies that they, by the way, they had healthcare records for 30 million people, 30 million, 1/10 of the US population. And one of the vendors was Salesforce. And they said, yeah, Salesforce has got 30 million healthcare records. And I said, that doesn't make any sense. Why would you put 30 million healthcare records in a CRM? You only have 200 employees in this. You're a little tiny company. What on earth would you do with 30 million healthcare records in a CRM? Well, they went back and looked, and they found that Salesforce is not one of their vendors. They came back and told me it was their customers' vendor. And I told them, this is not about your customer. This is about you, your vendors. So that was the first thing that was wrong. The second thing, one of the vendors happened to have two versions of their product, a cloud-hosted version or a version that you could install in your own enterprise. And they didn't know which version they had. Well, if it was a version in their own enterprise, it doesn't need to be in this calculation. It's not going to be a third-party data breach. It'll be their own internal data breach. So a point I would like to make is the important part here is the data that you're going to put into the calculation, and that's the hardest part to get right. And a point that I've been making with Tim is it's really important for audit to be involved in this. It's audit that's going to be able to assure that the data is correct that's being put into this. Is that good, Tim?
Yeah, that's good. Now, there's a couple questions that have come in, and particularly one from one of my former coworkers saying, you're projecting a common residual risk score across all third parties with the assumption that companies will arrive at the same residual risk given their mitigating controls.
Well, but I showed you data from really thousands of companies. We find, now remember, we derived that equation, the BPI equation. I showed you with algebra, we derived it from the first principles. So we know that that equation is right. And that equation is telling us we can use the average. Now the average, when you look at those Gaussian distributions, the average is really an average of bad vendors and good vendors. But we know mathematically we can still arrive at the correct answer using the average. And then you could say, well, maybe companies have different averages, but we don't see that. We see when we look across companies, the same average probability for their third-party lists. But if you think you're special, you can go calculate it. And then, like I said, in the white paper, we tell you how to calculate an average for your enterprise if you've experienced some third-party data breaches. You can go calculate it. I think you're going to find that it's within our standard deviations that we find. But, and it's not to say that you can't do better than average. You definitely can. But today, with the methods that people are using, the SOC 2 reports, questionnaires, and bit-side scores, everybody's pretty much the same average. All right, these are all really good questions, by the way. And it's telling me people are getting it. I want to pause just for a moment to show you, we just worked the first problem in the white paper. This is from page 12. It's on the top part of the white paper, how to implement the calculations. And this is under the subheading, examples. You can see this is a screenshot of the first one, the first calculation. There's the 13 third parties. There's a description of the calculation right here. And then we put also the results in a table. And you can see that in the white paper, we actually use a standard deviation in the calculation. So we've added the standard deviation and subtracted it. So it's actually a range in years. So if you're on the good side of the standard deviation, it'd be, well, the good side would be over here. You'd be once in 197 years. That would be outstanding. And if you're on the bad side of the standard deviation, it'd be once in 83 years. But once in 83 years is still a really pretty good probability. It's basically saying this data breach won't happen. All right. Patty, are you ready? I want to show you something really cool in the white paper.
Right.
So if you could open up the white paper and scroll down to the table of contents. Patty, tell me when you're there.
I am there.
Okay. Right here, it says reference table of probabilities per number of third parties. Could you please click that link? And I want to show you what we've done. So it'll take you to this table. And we've already calculated, good. We've already calculated all the numbers for you. As long as you're going to use the median value or you think you're within the standard deviation, we've pre-calculated everything for you. And in fact, so here's the median, and you can see the frequency in years. And there's up is at the lower standard deviation, the upper standard deviation, or vice versa, whether you're adding or subtracting. And if you scroll down, here's the example we just worked. There's the 13 third parties. There's the once on 117 years, and there's the standard deviation, 83 to 197 years. So right now, if you know the number of third parties in your organization that could expose data, right now, you could
Unencrypted.
look it up. Yeah, unencrypted, not obfuscated, could really expose it. Then right now, you could go look up and you could know the probability for your company. You can find it. And I got to tell you, I've given this workshop a few times. People have done it. They've told me they've looked themselves up. Now, you may not know because companies aren't used to knowing that the number of third parties matters. But anyway,
What's
should know the
important to
Excuse
table.
see
me.
here. Go
Sorry.
ahead, Patty.
Just noting the time, it's 12:55.
Oh, we better get going. We got another poll here.
Okay, let's see.
Do we want
Let's
to?
do this one.
It's important to get to the second problem here. It's the best problem, and it's one where
Yeah.
we actually have different
Right.
amounts of data that could be exposed.
Okay. I will cut this off in just a minute, okay?
Okay. This is important for the auditors. Auditors are very important. So we got to make sure they get their CPEs.
And this question is based more on your experience
Yeah,
and your
true.
thoughts, not so much on what we've presented.
Okay, I'm going to shut it down. So what we had is lack of visibility into vendor systems is the highest by 64%. And then too many vendors and limited budget are pretty close with a little bit of inconsistent vendor responses.
Wow, tell me about it. Good questions, good answers. Okay, let me get into the second problem here because this is the most important one before we run out of time. So another story problem. This is a big company. This company has 390 third parties that could expose small amounts of data. They have data on from 1,000 to 20,000 people. And then I have a much smaller number of vendors or third parties that it could expose very large amounts of data on 1 million or more people. Okay, so to approach this problem, I'm going to mentally think about two circles. And in the outer circle, two concentric circles. In the outer circles, I'm going to place the 390 third parties. These are the third parties that could expose small amounts of data. And within that, I'm going to create a second circle, and that's going to be the 15 third parties that could expose the very large amounts of data. And the reason I did this is because I'm going to do two calculations here. And the first calculation is going to include all of the third parties. I'm going to add the 390 to the 15, and I'm going to get 405 third parties total. And I'm going to label this as 1,000 plus people affected. And the plus sign is because it includes the 1 million. But and so it could be the probability I'm going to calculate for this could be the 1 million affected, but it's extremely unlikely. And the most probable data breach I'm going to calculate here for these 405 is a small data breach. But I'm also going to do a calculation for the 1 million plus people affected. And I put it in a table just so you could see. So for the small data breach, the 1,000 plus, I'm going to add the 15 to the 390, I'm going to get 405. And for the 1 million people affected, the 1 million plus, I just got the 15 third parties. And by the way, if you're wondering why I do this, you always calculate the probability for a range of data breach sizes. You never do it for exactly 1,336 people affected. It's always a range. And so these are my ranges. And so can I ask you to calculate the probabilities for 405 and for 15? And we're going to use our favorite breach probability index. And I want to remind you, we want to use a 0.066% probability. And I'm going to bring up my calculator, and I'm going to do the calculation too, and you could calculate with me. So I'm going to start with the small data breach first. So I'm going to enter, I think I've started my movie here. So I'm going to enter 405 and times, I'm going to use a percent key, 0.066% equals. So that comes out to 26, almost 27%. Then I'm going to invert that, and that's going to give me the frequency in years. So that's 3.7 years, or about once in 4 years. Okay, and I'm going to clear that. Now I'm going to do the big breach. So I got 15 third parties times 0.066%, and that's 0.99, or about 1%. And I'm going to invert it, and I get once in 101 years, or 100 years. Okay, that's the calculation. I'm going to go a little faster here so we can complete most of this in our first hour. Okay, so this is what I got. I got a really high probability for the very small data breach and a really low probability for the large data breach. So how would I talk to management about this? I would say this is a data breach that we should expect, once in 4 years. In fact, we've already had this data breach. I know we had, because this is a big company. First, I can tell from the number of third parties, and we got 405. So I know we've already experienced this data breach. So what I would say is this is just about what we've experienced. When we look back in time, this is about how often we experience this data breach. And I would say, by the way, don't blame the CISO. It's because we have 405 third parties that we've chosen to share small amounts of data with. For this very big data breach, I'm going to say we're reasonably assured that this breach won't happen. Once in 101 years, forget about it. It's not going to happen. And so this is the kind of result we want. The small breach is going to happen. The large breach is not going to happen. And I'm going to pause here for just a moment. Tim, do we still have enough time? Can we run your demonstration?
I think I think we probably shouldn't, so you can get to the how, the B to C, into the B to C
Okay.
example. Because the
Okay.
template's got the instructions in it.
Okay, let me tell you all the calculation. The ones that I've just done are in the template that we gave to you. We went a little slower. We started kind of late here, but here I'm going to skip this. This is a movie of the template, and I'm going to skip over this if I
There's
can.
tabs in there for instructions. There's a place for you to list all of your third parties and the amounts of data that they have. There's the quick and dirty calculator for the BPI calculator. There's also our contact information if you need to reach us.
Yeah, and then here's just the output from the spreadsheet. It just mirrors what we just did with our calculator. It tells you don't need a spreadsheet for everything, but for the 1,000 people affected, the spreadsheet calculated 27% or once in 4 years. And for the very large data breach, the million or more affected, we calculate 0.99 with our calculators, and that's what the spreadsheet got. And it also calculated 101 years. So the calculation is, of course, just exactly the same thing that we would expect. But we sort of show you an example. You can paste down your third parties. It's a good place to keep a record, and it does the same calculation you just did with your calculator.
There
Oh,
is a
we have
question.
another poll.
Let it go.
Sure.
Go ahead.
Oh, skip the poll? Okay. Go ahead with the question.
There is a question regarding like fourth party vendors. Are we
Good question.
Great question. Okay, where'd it go? Does the calculation only take into account your immediate partners / third parties? Do their partners, subcontractors, etc., figure in any way?
They do, but in a very sort of more abstract way. That 0.066% includes, believe it or not, fourth party. Because if you think about your third parties, one of the ways they could expose your data is through one of their third parties. So it's actually built into that 0.066%. But just now that you mentioned fourth parties, it's very interesting. One of the things I recommend is asking your third parties, asking for how many third parties they have that have your data. And you can calculate this also. I mean, think about it. The 0.066 works for them. Also, it's most likely the average probability for them as well. So you could do this calculation for them, but you cannot add these numbers up across your third parties, fourth parties. The reason I could explain that more later if you want to reach out to me, but the reason is a lot of your third parties are going to use the same third parties themselves, and so you can't add the probabilities. Okay, I know that's a complicated explanation, but you'll discover when you work with your third parties, a lot of them are using AWS, for example, or some other, they're using Microsoft, and you'll find Microsoft is used over and over again among your third parties, and you can't count Microsoft over and over and over again. That would be an incorrect calculation. All right. Sorry for such a quick answer, but it's a really good question. Okay, so if we could just go back to the 0.99, remember that's the probability for the very large data breach. That's the probability for the 1 million, the data breach that would affect 1 million people. And I want to answer the question, is this really a good number? We know that it's a good number for us. That's once in 100 years. So it's basically saying the data breach isn't going to happen to us. But what about the public? So to answer that question, we need to shift our perspective. So up to now, we're just thinking very selfishly about us. But what about the public? And I put Homer here because he's not such a bad guy, but he's a little bit just dopey sometimes. And I would like to propose a bit weird dopey when it comes to this. So I'm going to use Homer as our stand-in for us. So to answer the question, is it a good number for us? I want to step back a bit and remind you. So we have this equation, N times P average, and this is a very general equation. We derived it from first principles, linearity of expectations. It works for golfers, and Patty, I'm sorry there's no female golfers here, but it also works for third parties. We used it for third parties. And for the P average, we use 0.066. And I would like to point out that's for B2B companies. The 0.066 is for B2B companies that we've analyzed, thousands of them, from third-party lists that we've been given. Okay, and we use that and we calculated a 0.99% probability for a B2C company, a company that deals with the public. Okay, and now we want, and that's their probability for exposing 1 million or more records. Now we want to ask, what about the public? And we can use the same equation again, the N times P average. But now N is the number of organizations that you and I do business with. And I'm going to just pretend it's 20. Now, I don't know how many, but 20 is about right for me. I don't deal with
Tom,
very many companies.
Tom, you need to explain why the 0.99 versus the 0.066.
Exactly. So let me explain that. So I'm not going to use 0.066 for P average. I'm going to use 0.99. And why? Because we want to answer, would 0.99 be okay? Is a P average for B2C companies, companies that deal with the public. And if you're wondering why we're not using 0.066 instead of 0.99, it's just, I ask you, did you ask for a SOC 2 report from your bank? Did you give a questionnaire to your healthcare provider? I know the answer is no. So I want to propose to you, B2C companies are not under the same pressure that B2B companies are. And you shouldn't expect that they have the same very low probability that's due to your due diligence. So the calculation we're going to perform is we're going to use the 0.99 and we're going to ask, is this okay from the public's perspective? So here's the calculation we're going to do. This is you and me. We're the public. We're going to imagine we deal with 20 organizations. We're going to pop in this 0.99 and we're going to assume you and I deal with 20 organizations. And could you please calculate the probability and the expected frequency for your data to be exposed? And I'm going to do this calculation too. So, so get your calculator out. So we enter 20 times 0.99. Sorry, I stopped it. Okay, percent key. And we come out to 20%. And now I'm going to invert this to get the frequency. And I get 5 years. Okay, so you and I, if the average B2C company has a 0.99%, once in 100-year probability of exposing all their data, you and I should expect to have our personal data exposed every 5 years on average. I guess, so I ask you, is that acceptable, members of the public? Personally, I kind of think it's okay. I don't know.
It feels
Patty
like
says
it's more often, actually.
yeah, maybe many people have said it's more often than that. I don't know. I'm not keeping track. But okay, so going back to, if I was speaking to management with these numbers, I would say, and this is probably also acceptable to the public. So it's, all these numbers are good. It's reasonably assured. We're not going to have a breach. It's probably okay for our customers. And I think that we can take a once in 4-year probability for a small data breach. Before I conclude here, if you still have people here, so good, people haven't left. I want to make an argument for being accurate, even for the small data breach. And a lot of cybersecurity people have said, The only thing that matters is the large data breach. But I would propose the small data breach matters, and it matters for credibility. And I want to just go through what the discussion could look like with management. Imagine you tell management, we're reasonably assured that this large data breach won't happen because we only have 15 third parties. But imagine that they say, yeah, but how do you know there isn't a bad apple among those 15, right? Maybe you're thinking that yourself right now. Well, what you say is, sure, maybe there is a bad apple among these 15. But if there is, I've got 27 bad apples among this 405. But guess what? We calculated we should expect a third-party breach every 4 years. And that's exactly what we experienced. We experienced exactly this. So this can give management the confidence that you're doing the calculation right, that you really know how many third parties you've got, that you're exposed through, and that this calculation, the one that matters most, is also correct. So that's why we need to also look carefully at the small data breach. It's a science-based approach. We're making a testable prediction, and that will give management the assurance that you're doing this right. Okay, this has taken us a long time to get to this point. It's taken us more than 40 slides, but this is where we would like companies to be, not necessarily this is where they are. But just to remind you, we could assure management that that large data breach won't happen. And we can do that because we're limiting the number of third parties. In this case, we only got 15. We observed that the small data breach happens every 4 years, and we know why. And it's because we got 405 third parties. And maybe that's a good thing. The company's really using a lot of third parties. They bring a lot of value. And also, finally, we're presenting a reasonable risk to the public. The once in 100-year probability is okay for members of the public. Okay, I sort of rushed through that. If you've got comments, maybe you can stick around and ask more questions. But I want to go on and let Patty talk about risk budgets.
Sure. This slide, and by the way, there's only one more slide after this. This slide is intended to introduce a concept. We're not going to get too deep into it, but we wanted to get you thinking, and what can I do with this methodology? How can I help my business? So what the concept is the allocation paradigm, in which we're going to ask you to think about setting an achievable probability threshold. This is not by the way, this is not a financial budget. This is a risk budget. And establish a threshold. What is your tolerance? And then pinpoint those vendors with the potential to expose the data and ensure you're being a bit more accurate in those assumptions. Sum up your vendor probabilities, and you can use the BPI calculator for that. And then monitor the cumulative risk as it increases, and report this to your leadership. And then you can discuss ways to mitigate risks that maybe you hadn't thought of before, and focus on those vendors that contribute to the largest portion of the cumulative risk, and conduct root cause analysis and implement mitigations. So the tail vendors is something we refer to as part of this concept. They're those vendors that can really increase your risk. And think about things like, what can you do with those folks in terms of encryption, reducing the amount of data, and making sure that you're not asking them to store publicly available data. In other words, just let's try to move the needle.
Yeah, I got it. Can I second some points that you made? So
Sure.
The concept of the tail vendor, and some vendors are worse than others. The calculations that we've shown you today, we've assumed all vendors have the same probability, the 0.066. That's the average. So there is no distinguishing vendors in this calculation. You could use your judgment, but it's really hard to factor that into the calculation. So the concept of a tail vendor, you should know that it is possible to apply a regression model to your third parties. There you can actually discover very large differences between third parties. We do have a model. It's based on cybersecurity staffing level and the number of people with certain certifications. And that can be very powerful. Now you can really discover companies that are, eating much more of your risk budget up. So I want to mention that. Also, you want to be able to create different budgets or different thresholds for different size data breaches. I mean, you definitely want a low probability for that very large data breach. And you could be much more relaxed with a very small data breach. I also want to say there are so many things that you can do to stay within the threshold. Maybe you don't do them today because you don't have this concept of a threshold. You don't know what the probability is. But once you know, and you want to try and stay within a threshold, it can justify a lot of things that you could do that you wouldn't do otherwise. Like maybe you can obfuscate data, but it would cost you money. But now you could say, well, now there's a justification because we'd like to stay within our threshold. So we won't share a million records with any more than 15 third parties. If we want to, we're going to have to obfuscate the data or maybe, take data away from another third party. So I want to make that point too. There's a lot of people think there's nothing you can do. There's so much you can do once you have the picture. Patty, do you want me to go on?
Oh, sure. Yeah.
I
Getting the picture
forgot that was
accurate.
animated.
That's okay. Getting the picture accurate is for some companies a lot of work. And it shouldn't be done in a silo either. I've found great partnerships with the folks in data governance. They seem to be really keen into making sure that you've got the right data, it's tagged correctly, which can only help you with your exercise with trying to get your inventory straight. And by the way, the new NIST CSF 2.0 has a whole new section on governance. And within that, you've got GVSC, which is all about supply chain management. So using something like this risk budget, as well as just the calculator, can really help you demonstrate to your internal and external auditors and certifying and attestation bodies that you've got a more mature process that's repeatable and accurate and defendable, and that you will continuously monitor against. So it helps you in demonstrating compliance in that way, as well as on many others. This particular slide is to just provide you with a roadmap. Okay, we've presented lots of information to you. It can be overwhelming and like, where do I start? What do I do? So this is intended for you to take back and use it as a guide. Almost you could make a procedure out of it to help you with implementing this. And it's a 5-phase approach. I'm not going to go through all the phases. We've kept you long enough. But I would want to say that preparing your initial estimate is probably going to not give you the best optimal outcome in terms of reality, but it's a way to get started. Okay, it's a way to get your mind around this in a different perspective. And you can, and then share the white paper, share what you've done. You can show using the calculator, you can show using the tables to folks, and introduce this to your risk committee, your chief risk officer, your director of risk assessment, et cetera. Just get the introduction out there and then go back and refine your estimates and your calculations and your data so that you can have a very more detailed, more accurate presentation. And continue to report on what you're finding and what you're monitoring to your leadership, along with action plans, right? It's great to report, but if you find out, hey, we're kind of going off here, let's figure out together how we can mitigate and reduce those risks, propose remediation plans. And finally, don't forget to continuously monitor. That's a very key factor in all that we do, and update your policies and your procedures with this new concept, and track your third parties and their access to your data. So this is just a way for you to get started And we're happy to support you if you have any questions. In the template that we're going, yes, so many people have asked, are you going to share the slides? Is this recorded? Can we have the templates? And the answer is yes, yes, yes. So they'll be available on the ISACA site. And as well, if you want to reach out to us directly, we're happy to help you. And with that, I wanted to thank everyone for their patience and attendance today, and especially for our friends at ISACA.
Do we want to answer questions or?
Absolutely. We have 8 minutes.
You want to bring up your last slide anyway, perhaps. But the one thing I was going to say on this slide is third-party inventory is where you really want to get your auditors involved and go completely across the organization, because all too often anymore, there's a lot of shadow IT. So people down in the various departments can be sharing your data and you don't even know about it.
I just really want to second that. What I find is the first time you do this, the data's wrong. And I do think audit is so important. It's going to be, in the end, the credibility here is going to be from audit. Audit is going to be the group that says, yes, indeed, this is a complete list. These are only the companies that could expose data. So I want to emphasize the importance of audit. Can I say something about the phase 2? Remember, the white paper has that second section, and it's for it's written really for senior management. It's written, if you're in a bank, it's written for model validation. So it's written
Okay, hey,
in the
Tom?
language of, yep.
Can I drop the third poll? People are asking for it. Can we go back and
Oh,
drop
sure.
the third poll?
Sure. There's also a post-workshop poll that I would really love if people could respond to as well. That will help us improve our process going forward. I'm putting
No
that in the chat
questions?
as well.
You know, I want to make an observation that if you're CISO, you're not really in charge of third-party risk management. This is a calculation you can do, and it has nothing to do, in a way, with third-party risk management. I mean, all you need is the number of third parties. So it's very easy for a CISO to report to senior management, for example. By the way, here's our risk. Sort of separate from third-party risk management. They're doing their job and I'm doing mine, and I'm just giving you information on the likelihood of our company having a data breach. And I've had CISOs do that sort of independently.
Do we have the poll responses, Tim?
Yeah, so we're up to about 29 out of 40 people, and the prioritized third party with lower data breach probability is like 62%. And only consider it for a number of third parties is in second place. So that's looking good.
Right.
Sorry for holding off on this polling question, you guys. I was trying to make sure we got through the content as well. So it's kind of a delicate balance, if you will.
No questions, is that right?
Yes. So someone's asking, is there a place to go to contact details of the presenters? Yes. How do we reach out to you directly? In the template, we'll have our LinkedIn's. I can post mine.
And I posted mine. I think you already did, Patty, but we'll do it again.
Yeah, I did. Do you want to repeat it, Tim, or should I?
Well, you can post yours, I'll post mine.
Okay. I did put it in here. Oop.
Yeah, if anybody wants to reach out to me on LinkedIn, I'm Dr. Thomas Lee, Viva Security. Your feedback is important. This is a really hard workshop to give. And we've practiced it a lot. We've gotten a lot of feedback. We need a lot more. And so if you could the poll is important for us. If you could do the ending poll, but also
Yeah.
if you could reach out, if you've got any comments on how we can improve this, how we can better communicate. This is, can I tell you, we spend our time with the data, and I can tell you that a third-party data breach is the most likely large data breach for large companies. And it's a big deal. And we could begin to change and reduce the number of these third-party data breaches if management can just understand the risk. They'll know what to do, and you can help them do the right thing. So this is like a very important thing to teach, and I'd really appreciate it. Any help that you can give us in how to improve this workshop. Also, if you know anybody that would like to, any other places
Oh,
we
yeah,
could give the
absolutely.
workshop, we hope to be
And
giving this much
also,
more.
Thomas, we'd like to show the lead up to that, the ISACA workshop that we did, you know, that got us to understand the
Oh,
equation.
sure. And we do have more workshops that we plan on doing on how to use this data, how to communicate it, how to do risk budgets. And you should know that Tim and I are working, not real fast, but on a paper just for auditors and how they could begin. And any feedback, by the way, you have on this would be very helpful. But how could audit begin looking at this problem within an organization? Gosh, it's hard to believe nobody has questions. Maybe they're
There
chicken.
is a question from JP Wilson, and here it is. Might there be a tie in between TPRM and reducing the opportunity to potentially significantly disrupt business operation integrity? Yes.
There's definitely, I want to tell you that the really neat things about these equations is they don't only have to apply to third party. And indeed, disruption of operations is a really big deal, and maybe much bigger deal than data breach. But we just don't have a model for disruption of operation. But a lot of companies have enough data internally, so you could apply the same math for disruption of operations. And JP, you and I can talk about that. I can show you how to do that with these calculations. This workshop was only for data breach, but you're right on the money. And I think that this is a valuable calculation for many other risks that third parties could bring. Or even, well, third party is a really good cause for data, for disruption of services. Well, we're right up on
Okay,
an hour
we're
and a
at
half.
time.
We still have attendees out there.
They're
Does
waiting for
anybody have
somebody
any
else to ask a
questions?
question.
Let's see.
Well, I could say thank you everybody for coming. It's an important problem. It's a hard workshop to present. I really appreciate your patience. Nobody complained. All right, anyway, I couldn't see the complaints when we showed
We're
how
saving
to
those,
derive,
Tom.
for the math. I've been told never show an equation, and we showed lots of equations. But gosh, this is the 21st century, so gosh, everything works on math. So anyway, I appreciate everybody coming, and any feedback would really be helpful.
There is one more empty slide.
Wow, look at that.
It was the Beth Mask class.
I appreciate that.
That's great. That's awesome.
Okay, guys.
Can you tell that boards and C-suite executive delusions
This is
have
a
no
really
idea the
good.
importance of TPRM?
Oh, I'll tell you, this is for business. I mean, I got it. They caused this problem. They could fix it, but they just don't know. So just to emphasize, it's a business problem, and they can't fix it until we can report this risk to them. And believe me, this will elevate third-party risk management. Yeah, but they understand this. Believe me, they'll understand this. They totally get it. We just have to report it, and it will, in the end, it'll elevate the importance of third-party risk management within the organization. You'll be now at the table because third parties bring such value to companies. And if you do this right, the company will be able to use more third parties. So not fewer. I know it looks like it's fewer, but it's, think about the 405 third parties in the example. All right, I'll stop talking.
Okay, thanks, everybody.
Thank you.
Have a great weekend.
Okay, guys, take care. I'm gonna
Bye-bye.
close it out now.
Okay.
And Patty and Thomas, see you on the flip side then, okay?
Okay, bye-bye.
Bye-bye.
Bye.